so we'll go ahead and get started with the webinar today. Hi, my name is Kayla Sangster. I am the Channel Marketing Manager here at Solid, and I just want to thank everyone for joining today on our webinar, Is Your Building Ready for 2020? Our speakers for today are going to be Lakshman Thiagarajan, Senior Director in Engineering Certification and Design at Solid, and Nadir Famili, PhD, SVP of Technology Planning and Development at Connectivity Wireless. So we're really quickly just going to go through a couple of housekeeping rules for the webinar. Today's webinar is scheduled for 1 hour, including question and answering, so we'll have about 10 to 15 minutes at the end of this webinar for that. All attendees will be muted throughout the presentation, just so that the speakers are able to present without any interruption. If you look on your panel, go to webinar panel on the right-hand side. There will be an interactive chat available throughout the presentation. This is where you guys can go to ask your questions for our presenters, and we will go over those the last 10 to 15 minutes of the webinar. And finally, the webinar is being recorded today, so we will send out a link to all attendees and those who were not able to attend approximately 72 hours after the webinar. So at this time, I'll go ahead and pass it over to Lakshman.
Thank you, Kel. All right. Good morning or good afternoon, wherever you are from listening into this webinar here. We want to go over a little bit of the technology and understanding where the market is today and where it is absolutely moving towards in order for you, as whether you're a building owner, whether you're an OEM, whether you're a manufacturer, whether you're a vendor, to really get part of where the industry is moving. And what my colleague here, Dr. Famili, will do is take it over to understand a little bit more of the technical aspects of what this really means for you. So in this first section, I'm going to cover with you the different aspects of innovation that we as an industry, and also specifically a little bit about what we as Solid are doing, and talk a little bit about all the different kinds of technologies and state of affairs that we're currently working with in the market. So one of the first things we did was really try to define what is really being ready means. And that we took advantage of, obviously, our large customer base, our industry is very, very vocal, trying to understand really what are the current problems that you're facing as a user today. And I'm sure everybody on this webinar here can relate to at least one or more of these topics that we have seen as part of the word cloud that we put together, which really clarifies all the issues and concerns that we are seeing today, whether it's spotty coverage, whether it's not good consistency in terms of signal levels, whether it's cost, whether it's spacing requirements. All of the above are very, very familiar to most people. We've seen this evolve from the days of 4G, and obviously we're going to continue to see more of it as the world evolves towards 5G and beyond. So it's very evident in terms of what we're dealing with today. So what is we as an industry and we as a company can do, trying to define it a little bit more specifically as to what some of these look like. One of the first facets that we as a building should try to do is obviously improve the user experience and quality of service in every aspect as possible. We expect, and we really as a user want to have increased mobility and reliability all across the board. Future technologies is very huge. I started off in the industry, myself working about 10, 11 years ago, transitioning 2G to 3G. So I started building a lot of systems in the industry, fixing a lot of systems. And as we have evolved from some of those systems to today to support 5G, is that much more imperative that the solutions and systems that go into these buildings and closets, whether it's the physical cabling infrastructure or whether it's the actual equipment infrastructure, there is no more allowances for ripping and replacing of forklift upgrades. So future technologies have to be assumed are always going to be part of these builds that we're doing. And the solutions that are going to accommodate these much more seamlessly are the ones that continue to win out. And certainly efficiency of the infrastructure. Today, as the world, we are moving towards a much more greener type environment, power consumption, spacing requirements, and really sort of the OpEx costs of these solutions have gotten that much more focused as much as CapEx. Prior times, we always only worried about the OpEx costs, but today the OpEx costs are also significantly very, very much more scrutinized in terms of trying to make sure that we're putting the right solutions in. And lastly, the world of where we live today is actually a world of technology, different technologies actually complementing each other. Traditionally, one of the things that I've been perennially asked by a lot of customers is, should we do Wi-Fi? Should we do DAS? Should we do small cells? Should we do different types of other solutions, IDAS, ODAS? In reality, the question that we should all be asking ourselves is, should we basically be doing all of the above? Because there's definitely a right solution for the right venue type approach, but also there's also the right solution can mean it's a gamut of different services and technologies and infrastructure that can really help become the most efficient in terms of the building's needs. This is primarily driven by the simple fact that every building and every venue and every service that we're looking for today, connectivity-wise, has very different requirements. So not all buildings are built the same. Not all services are required to be the same. So rather than simply build everything for everybody, we're really trying to build horses for courses and trying to really help technologies work together instead of competing with each other. And where does innovation really come into play? We are certainly working with a lot of different technologies, and innovation really is driven by the simple understanding of we're tying different existing technologies and ideas together to bring something valuable and useful to the industry and to the market that we're facing today. And innovation can come in many different aspects, right? We're talking about infrastructure. So whether that's the actual cabling or fiber infrastructure or the actual boxes that go in different areas, that could be a significant place where things can change and are changing. The processes, in the past, we traditionally had 3 or 4 different key stakeholders who worked on these systems, but today the processes for all of this is varying quite a lot. There's newer ways of doing things, and that's going to be a significant aspect to how we can actually start to make these systems much more future-proof and much more efficient. Cost certainly is probably, I think, the backbone of everything that we do today. The cost has to be lower. It simply cannot be at the prices that we're working with in these buildings and systems. What kind of order of magnitude? We at Solid are believing that we can probably reduce these costs down to 30, 40%, 50% lesser, in some cases, probably beyond more. We are not afraid to dream big, and that's kind of where you will see, as I conclude my presentation in a few minutes, you'll see where some of our innovation and our strategic roadmap is lying in terms of cost. The sources, the capacity scaling, and the non-converged network layers are more driven from the technology aspect. But obviously, all of that will also continue to drive towards making sure that we can certainly ensure that innovation can truly be driven. And as a end user, as a manufacturer, you have to understand that all of these different facets have to evolve and innovate in order to make the end user or the system that we're building today successful. While we don't really talk a whole lot about technology, and my colleague here, Dr. Famili, he will expand on a little bit more of the technical aspects, as I mentioned. But today, most of our world that we're dealing with, at least 4G speaking, is sub-6 gigahertz. As for those of you on this call who are very technical or understand technology, we all probably understand the simple fact that we're all limited by spectrum. It's probably the most scarce resource available that's out there, or lack of. And we're dealing with sub-6 gigahertz, which is where most of the traditional DAS solutions or small cell solutions or 4G type solutions are based. As we are evolving, as we're innovating, new spectrum, new methods of using the spectrum are starting to come up, specifically around, like, let's say, a concept like millimeter wave, driven by, some operators here in the US. Millimeter wave is obviously a newer spectrum. It's newfound ways of utilizing the resource that we absolutely need to make sure that future networks can be supported. But this also, what it does is open up a lot more business opportunities for everybody out there. People who are using the spectrum, consumers of data, creators of data, as a building owner, as a manufacturer, is starting to open up a lot more business opportunities. So while spectrum is something that traditionally has been very, very expensive and very, very hard to procure and build out, in a different way, we as a user, and especially handset manufacturers, for instance, are starting to innovate to bring out new handsets that will support a lot of these newer spectrum. So today, the world is not about just simply using lower spectrum or mid-band spectrum. It's actually a combination of using the low, mid, and the high, and how can we continue to offer seamless mobility for the end user. So that's where this really comes into play. And but it's not fraught with challenges. All of the spectrum is absolutely useful and is important, but it also has very, very different characteristics as far as propagation goes, as far as the use cases goes. So it's again understanding where the spectrum is being utilized, which type of venues need what type of spectrum, and how are we going to implement this, all of it at a cost that is going to be feasible or acceptable to the end user. There's no point of putting a technology out there that is bulletproof, but it's not affordable. So there's the constant trade-off that we continue to work with in the industry, and with newer ways of solving these problems, this is becoming a much easier problem, but certainly something that we all need to understand how to actually make it happen. And here are some of the different types of technologies or connectivity solutions that we have probably seen or heard of. Now, one of the key things I want to point out is a lot of this that you see here is not really new, or it's not necessarily very innovative. The ones that are really going to stand out, or the ones that are really going to survive, are the ones that really disrupt the industry today. And that's really the key word. While innovation itself is great, while innovation itself is necessary, the innovation that truly disrupts the industry, that's really what's required for what we're trying to drive towards. A lot of these types of solutions have been already tested, proven. Some of these are yet to be proven. Some of these are expected to be very successful. But what is going to truly be disruptive is certainly going to be maybe some sort of a combination of these, or a couple of these that stand out as opposed to some other aspects. The one thing that is absolutely sure is being able to drive as much network intelligence to the edge as possible, as much data to the edge as possible. And that's all going to be driven by using the right type of infrastructure, specifically on the backbone. So we have a lot of different solutions, a lot of different technologies, none of which is really new to begin with. The SAS here that you sort of see in the center of the slide is actually very, very key, especially for those folks who are looking at private LTE spectrum or CVRS band, for instance. And if you haven't followed the news really closely, just as of yesterday, so this conversation here is very timely, just as of yesterday, the FCC actually finally conditionally approved 5 SAS providers to start initial commercial deployments officially. CPRS itself has been talked about or approved by the NTIA since 2015. So we're 4 years into it. So obviously we've done a lot of the legwork, groundwork, but 5 of the SAS providers can officially start building out their commercial deployments, and Federated Wireless is going to start launching live at least 36 states with CPRS spectrum. So a lot of excitement is going to be driven by something like this, and this is something very unprecedented, which is again where it's disruptive, right? So that's something where we expect to have a lot more players, a lot more possible evolution of the technology itself, because something like that has never been done before. So spectrum sharing and using the spectrum that's not typically available to the end user, but is now controlled by the end user, is going to be significantly both important and also understand what we can learn from that. And we at Solid are part of the ecosystem where we truly believe that every venue owner, every building owner is part of one of these 4 buckets that we see. These are what we like to call the 4 pillars of in-building infrastructure. So every enterprise is going to find a home, whether it's the impact of the technology, whether it's 4G or 5G, whether it's the type of signal source that you're bringing in, whether the need for public safety that's driving the innovation. All of this is where every bucket is. But the one thing that we absolutely believe and we want to almost advocate is plan on pulling fiber to the edge. Plan on having fiber to the edge, if not for today, for tomorrow's needs. That is a guaranteed a build. That's something that you will absolutely see the ability to enhance your technology, your resources, and it's really going to help evolve your system much, much more than you have ever been able to do today. So we truly think that the future needs, whether it's CCTV cameras, for example. I mean, every CCTV video or snippet that I have seen online is grainy at best. And we can shoot, obviously, 4K resolution pictures on our phone today. So the ability to be able to drive that at the edge and collect all this data is simply going to be driven by the bottleneck or the bandwidth limitation, if any, you have in your fiber infrastructure or copper infrastructure. And we truly believe fiber is the way to go for any future needs or applications. And what is the value innovation that we're really trying to drive? Here's a different way of how we look at it. Today, we are advocating new ways of evolving the infrastructure, as you can think of, like fiber to the antenna. Fiber to coax has been very traditional. We have always done that. We've had a fiber from a main location to a remote type location, and then you would typically have copper that feeds the last edge. And that last edge is typically the bottleneck, whether it's an IDAS type scenario, ODAS type scenario, small cell scenario, whatever it may be. But if we can get fiber to the edge, where again, the network intelligence and put all the processing or the virtualization as part of this ecosystem, which will help drive the overall cost down as well, you now get more bang for the buck and better return on investment. So the way we see it is we've got all these little localized hubs, right? You've got your data center, you've got your closet, you've got your digital ceiling. And primarily what's driving all of this is that last bubble right here, the devices. These devices are innovating and are being created faster and more advanced than the network can keep up. I don't think it's no secret that whether it's today the iPhone 11 that launched fairly recently, or at least was announced, devices like Samsung, Motorola, all of these are expected to support a lot of the newer 5G bands as soon as they come out. But these networks that we're currently still working with are barely able to keep up even with our 4G LTE service. People talk about 5G. Every RFP or every type of project that we respond to always asks a simple question: how do you plan to support 5G? What most people don't realize is 5G today, at least the first phase for the foreseeable future, 2 or 3 years down the line, is expected to have 4G as an anchor. 5G simply cannot work without 4G. So the first step to really answering that question, how a building can support 5G, is to truly build out 4G in the network, in the system, as best as able, with the highest levels of performance, because that will automatically help a seamless upgrade to support 5G. And that is how 5G phase 1 is defined. This is where all the technical aspects come into play, and helping understand and clarifying the needs of when you work with different partners and solutions providers to make sure that the system is going to basically be able to support the standard layout of 4G. And ultimately, everything is also going to be managed or controlled by what we think moving to the cloud. Today, a lot of our systems or a lot of the devices are typically localized control, perhaps running over some sort of IPsec tunnel, or maybe even a remote wireless modem. But moving everything back to the cloud will obviously free up a lot more of space, not just physical space, but also in terms of the ability to manage and control these systems from remote locations as possible. So in terms of value innovation, the end user end devices are really driving up what this is intended to be. And one common theme, if you see across the board for this slide, is looking at that fiber backbone infrastructure end to end, from where the cloud is all the way down to the devices. We believe that the fiber to the edge type solution is going to basically drive that innovation. And what we can see, today, what we have done sort of in a different way to look at it, on the left-hand side is the traditional infrastructure that all of us are very familiar with, where we have a lot of systems out there that we're currently trying to upgrade to support newer services, newer technologies, and they will continue to happen. They're not going to go away. But green buildings that are sort of more forward-thinking, buildings that are more, need more special needs, they're going to have newer technology requirements. IoT is huge. We already talked a little bit about CVRS. We talked about CCTV in 4K possibly. And this is really a sampling of what some of those end use cases can be. We obviously are trying to peer as far out in the crystal ball as possible. And where we believe, one of the things that I constantly get asked as well is, what is that killer application for 5G, right? For 4G, it was video. For 3G, prior to that was texting. 2G, it was more calling. So as we have evolved through different technologies, 5G killer application really may not exist, because it actually might be a combination of all of the newer applications that were coming out. Perhaps there is no one type of application that is going to define 5G, and that's maybe both the best part and probably the worst part about 5G. So the sooner we can adopt that, the sooner we comprehend that, and the sooner we can help build that, that's where really I think we believe 5G truly is going to be able to be supported for these new buildings. And these strategic type of alliances or strategic type of roadmap, that's where we at Solid are moving towards. So that's kind of where it comes to my final slide here before I hand it off to Dr. Famili is, we're really looking to disrupt the market from a cost standpoint. We truly believe that active building solutions have to reduce cost with different types of virtualization, developing newer products, newer solutions. Some of these numbers is what we're shooting for. We believe the future solutions can be a good 75% reduction in space and possibly even cost. This obviously throws up a lot of dialogue for different vendors and different folks, whether it's customers and competitors alike. But we can't achieve something unless we start somewhere trying to get to someplace. With the newer ways of what things have evolved, with what we believe we're doing, and with what we have seen in the market, being able to work with operators worldwide, not just here in the US, and what can be done, this is not too far out of the realm to reach. And this certainly obviously some folks may believe that cuts into a lot of profit margins, but it need not be the case at all. Our newer applications, our newer deployments are going to have different needs, different use cases. So the best way to look at these future technologies is to not think with the traditional mindset or technology that we have today. So we at Solid and myself here at Solid truly are committed to being able to get to a point where we can have these devices and systems at 15, 20 cents a square foot, possibly even lower. And we don't think that's too far out in the future to be able to get to that. Okay. As Kel already mentioned, if you guys had any questions, feel free to send it through the chat window. We will address them at the end of the presentation. At this point, I'm going to hand it off to Dr. Famili for the rest of the presentation here. Thank you.
You guys can see it? Kelly?
Yes, sir.
All right, wonderful. Hello, everyone. Thank you, Lakshman, for a wonderful talk. My slides are more focused toward the venue owners and venue managers. As indicated by Lakshman, there is the need for broadband connectivity inside the buildings like nothing else. And there's some drivers for it that are new, and those drivers could be substantiated by some of the new technologies that are coming. And then I talk about the importance of fiber by itself and the ways the venue owners and managers can make money out of all this. And where do we fit as a third-party operator, connectivity wireless and other players like us? All right, so why do we need in-building connectivity? I mean, that's common sense. All of you know that, but sometimes it's good to rehash what is common sense. The fact is that the bulk of the usage of broadband, whether it's wireless or not, happens inside the buildings. Wired Discourse says 80% of businesses experience connectivity issues. That is because the carriers, I mean, they've spent as much as money as they had, but the fact is all these buildings, especially with the LEED certification, more buildings have coverage and capacity issues. Then another number that's been bandied about for a long time is 80% of traffic is generated from indoors. That's just common sense, because when you're outside while you're driving or walking, it's hard to use your handsets or your laptop. So and all that together have brought us to the point where broadband connectivity is being called the fourth utility after gas, water, and electricity. It's not a luxury anymore. It's a must-have. And what it brings for the venue owners is some of the values are listed here. Competitive advantage, obviously differentiation, enhance the tenant experience, so retention is part of that, generate revenues, and we will discuss all that with a little bit more information. Strengthen the safety and security, because public safety and also security of the tenant will very much be improved using the new technologies that are available. And operational efficiencies, simply because a lot of the businesses are using the wireless and the wired as part of their processes. And when you give them better utilities, their efficiencies goes up. And all that is made available by broadband infrastructure. Some of the drivers, we always knew that connectivity, both wireless and wired, was very important. But now we've gone beyond important, and now we've gone to the realm of vital and crucial. And some of the new drivers that even make it more vital are enhanced mobile broadband that has been brought about with the usage of 5G. As Lakshmi pointed out, the 5G, especially in the initial stages of deployment, it's being utilized in the form what's called the non-standalone. Non-standalone means that it uses 4G as the anchor, and all the control channels basically go through what's known as the master node, and the other one is called the secondary node. So the master node, being the 4G, is where the control is going. So if you don't have a good 4G coverage in your building, then you better go get some using DAS or other ways, and then you will be able to put 5G on top of that. Multitude of other applications, obviously, with 5G will be even better in terms of voice data, video streaming, whatnot. And then the third one, which in my opinion is really the most important one, is the coming applications. Augmented reality, virtual reality, location-based services and whatnot. In augmented reality, in my opinion, is really a huge thing that is really coming like a freight train, and not many people are seeing that. I mean, if you guys have seen the Microsoft HoloLens, you know that in a few years we won't really be using any laptops anymore. We'll all just have those funny glasses and then be doing augmented reality, and untethered, not connected to anything, all wireless. And that can only happen if you have existing 5G in your building. Internet of Things, you all heard about it. Any smart cities, smart counties, a smart country, whatever, is built on smart buildings. And smart buildings means that you need to have the infrastructure in terms of sensors, cameras, whatnot, to be able to support that. Another big driver is private networks. Private networks have been talked about for decades, for at least 2 decades that I know of. But it's never been very possible, because one thing that private networks need is a spectrum, and that has never been available. Nowadays, with CVRS, that I will discuss a little further, that has become reality. So that would be a very big driver in our journey here. And obviously public safety. Public safety has always been important. Nowadays, public safety is not just push-to-talk voice anymore. It needs to be data, it needs to be video, and we all know the social and cultural implications of that. Some of the technologies that are making these happen are 5G, CVRS, carrier-grade Wi-Fi, and I also include fiber. Although fiber is not a wireless technology, but there was a cliche that no industry uses as much wire as wireless. I think that's a reality. The fact is that none of the above that I just mentioned over there are possible without a very deep penetration of fiber and fiber distribution in your building. Much like your Cat5 and Cat6 that you already have, the same deep fiber availability would be required in order to have the slew of services that we want you guys to enjoy in your building using those technologies. All of these technologies need to provide ubiquitous coverage, so spotty coverage doesn't do it anymore. Need to have enough capacity, need to perform well, need to be future-proof. Reality is that you don't have enough money to go and buy a new network every few years. It needs to be, whatever, 10, 15 years, at least the infrastructure. You would obviously have upgrades and stuff. And last but not least, permitting vertical application. Now, vertical applications at this time are not really popular, because if you even have DAS systems, everything goes back to the core of the carriers. Now, a lot of different verticals have their own specific needs, and I think Lakshmi pointed out several times that we need to be at the edge. Really, a lot of these services need to be provided at the edge, and that's what the vertical applications would provide you. So let's discuss a little bit about these technologies. We're not going to go obviously deep into any of them. There's no use for that. But a little bit of knowledge about these are I think, are essential. 5G really offers three things: faster service, which both in terms of peak data rate and average data rate, less latency. We talk about less than 1 millisecond. That is a little, hopeful, a little optimistic, but anything from 1 to 10 would do. Probably 6-9 availability, very high availability, and high data rates, because those are for some of the applications that really need them. For example, in industrial applications, you really, because they are controlling a lot of robotic systems, a lot of automatic systems. They really need the latency of less than 1 millisecond, and availability needs to be 6 nines, because any disruption to their systems means millions and tens of millions of dollars in loss. And the third thing that 5G would give you, which is again very important, is the IoT, which means right now systems really are designed and deployed for people. Going into near future, systems will be designed for things more than it is designed for people, and things are a lot more things than people. So any sector now can accommodate, I don't know, a couple of hundred people. In future, a sector is expected to accommodate maybe tens of thousands of things, and that's what density of millions per square kilometer comes into play. Also, another application of 5G could be fixed wireless. I'm not sure to what extent that would be useful. Not useful in the 6 gig and under 6 gigahertz frequencies, but definitely possible for millimeter wave. And I think Verizon is using that in millimeter wave, and to a great success. Next technology we want to talk about is CVRS. CVRS is not a technology. CVRS is a band that FCC, in its wisdom, devised a while back. I think in 2015 they came up with it. It's 150 megahertz. It's a shared band, which is really a first of its own experience like that across the world. There's no other experience like that across the world, where a band is shared in such a massive scale. I mean, there has been smaller bands which has been shared by a few individuals and a few entities, but it is not dedicated. Therefore, it's not expensive, not supposed to be at least. It's not licensed, so anybody can use it. So that really opens the way for private networks. It's shared, but if it is shared, that means it needs to have some sort of referee. As again, Lakshmi pointed out, it's SAS that we will maybe talk about a little bit. SAS is really called the Spectrum Access Systems. There's 5 of them approved in US, and they are the ones who basically referee where each transmitter of CVRS gets how much spectrum and for how long, and then it's supposed to not transmit. We talk about 3 layers: the incumbent layers, which are federal government, because that frequency is used by Navy, very few naval ships, very few of them, I think probably 10, I think I heard. Earth stations, satellites, the good thing about them is that they don't move, so they are stationary, so we can define an area around them and control the interference. And then some wireless broadband that is widely used everywhere, and that's the one that was massive in scale. Now 70 megahertz of that would be leased, and the rest would be available to everyone. All right, so the important thing about that, as I pointed out, is the fact that you can now do private networking. A private network with, even if you don't want to pay for PAL, if you don't want to pay for anything. So what you can do is you can apply for a GAA license, register for that. It's simple. I've done it. Not a big deal. Nothing. Yeah, don't have to pay anything. You register for that. Voila, you can use this spectrum, and you can use it in your private network. Carriers can use it for their own purposes. They have some plans. Cable operators can use it if they want to compete with carriers and provide wireless service. They can use CVRS and fixed wireless access. Again, that's probably if you buy some PAL. Otherwise, it doesn't make much sense. The neutral host wireless, the business that we're in, we can go build the system and allow other people to use it and charge them. Some of the other details, I don't think I have time for that now, but the important thing here below that is the sources of income. So if you own a CVRS network, which as a venue owner, you could do that. You can make money from roaming revenue from wireless carriers. You can make money from services inside that is used by your tenants, location-based, IoT, whatnot. And you can basically charge people because you have provided improved coverage. Now, the numbers to the right, not necessarily all very correct, in my opinion. The CPRS is actually cheaper in terms of the RAN, the radio part, simply because you only use one radio for everybody. But it really has the cost of core in it, which is not reflected here. And the next thing that I want to talk about, the carrier grade Wi-Fi. This is really, it's not your mom and pop Wi-Fi. It's not the spotty, just a lobby of a hotel or something Wi-Fi. It needs to be very robust, great coverage. You need to be able to do voice over Wi-Fi. Most importantly, you need to be able to offload carrier traffic on it. That would be a source of revenue. So it would be a source of revenue if you can allow the cable operators do their quad play on it. Comcast has been using Wi-Fi for a long time for that purpose. And MNOs also, if they have lack of coverage somewhere, they can use carrier grade Wi-Fi. If it's not carrier grade, they won't do it. But they have used carrier grade Wi-Fi. You go to the airports and you see that they offloaded on systems like Boingo's system. And you can do that the same. If you have an enterprise and if you have a carrier grade system, you can make money out of it the same way as Boingo is making at airports. All that is made possible by the newer technology from Wi-Fi that's called 802.11ax, or branded as Wi-Fi 6, much more improved than the previous version AC, and allows you to do a lot of those things. If you go and check to see what is carrier grade Wi-Fi and what are the standards for it, you won't find any. I've done that. So there is no standard, so I had to develop my own standard. So anyway, this is my standard. For better performance, better SINR, lower latency, and welcome to read that and comment on that. Anyway, I've talked about really 3 different technologies: 5G, CVRS, and carrier grade Wi-Fi. There's a lot of overlap between them, so the question may be, okay, now I have this building, which one do I use? The answer is not always this, that, or the other. The answer is really depend on your tenants, your use cases. If you have a lot of, and these are my opinions, anybody can comment on that, welcome to do that. If you have a lot of heavy traffic in and out of the building, you want the people to enjoy the same 5G services that they're enjoying outside, inside. So you want to have 5G DAS or 5G DRAN or some sort of coverage system there. And if you have existing 4G that is not good enough, you need to strengthen that before you use the 5G, as we discussed. CVRS, if you have internal applications such as industrial, neutral hosting, if you want to do that, and if you want to have extensive IoT, you know, all that, you really then need CVRS. And CVRS and 5G are not necessarily against each other. You can have 5G on CPRS because CPRS is just a band. But right now it's not available as far as I know, but yeah, I'm sure in future it would be. And carrier grade, you, regardless of what is the usage of your building, in my opinion, you should have it. And if you want to have carrier grade with something else, then you can bifurcate services, put some of the services on carrier grade and some of the services on the others. Fiber, as I said, fundamental. In order to make all those other things happen, you need to have very deep fiber everywhere. By itself could be a source of revenue and income for you. 150 billion will be invested by the next 5 years. I saw that, I think, a year and a half ago. So there's another 100 billion left to go there. Revenue opportunities for buildings. Again, as discussed, you can charge people higher rents for providing better services. You can charge them for having IoT connectivity. On top of that, if you're interested, you can have IoT analytics. You can allow the carriers and other wireless players to use your roof. Charge higher because of the operational costs, improve security, and work process improvements. So it's not about just spending money. You can spend the capital, but later on get it back from your tenants. And the last slide I have is having a system such as a CVRS system, a carrier grade Wi-Fi system is not always possible for enterprises who don't have strong capabilities in those regards. And it's not easy, especially with CVRS, because it has a core. So there are players like us and provide you as infrastructure as a service. We will build it for you, manage it, monitor it, upgrade it, and all that, and you know, would have obviously some sort of a monthly recurring cost. And that's another possibility for you. I think I'm done. Kaylee, I'm done. Thank you. We can go to questions, I think.
Okay, thanks, Nadir and Lakshman. I'm going to go ahead. It looks like we've got a couple of questions that have come in, so I'll go ahead and read through a couple of them. It looks like we've got about 15 minutes left. So the first question is for Nadir. What are your thoughts on the migration path from CVRS to 5G?
Yeah, as I said, eventually we'll get there. Right now, I've looked into CVRS systems existing. They're all based on 4G, simply because there are two types of cores for CPRS. You can have local core, which sits on a server, and with the 5G one right now, they may not even be available. If they're available, they're very expensive. And then they're cloud-based. The cloud-based ones right now are less capable. However, you know, in 2 years, I'm sure they would be much more capable, and they would be 5G. But you know, as we discussed earlier, a lot of the 5G systems will go through the processes of using 4G as an anchor, then later on being 4G and 5G together. The different options, actually, there's like 5 different options. But you know, the 4G would be with us for a long time, at least in my opinion, 5 years or so. So in the next 5 years, CBRS would primarily be 4G, in my opinion. But 5 years from now, would all be 5G.
Okay. The next question is for Nadir or Lakshman. What are your thoughts on how the enterprise verticals can recognize an attractive ROI by investing in the horizontal fiber to edge approach versus standard coax?
Sure, I could take this, and Dr. Famili, if you have anything more to add, feel free. So that's actually a very, very important question because today we're certainly advocating the need for fiber, the use for fiber, and I think one of the parallels I like to always draw is the simple home internet. We obviously continue to see any of the multitude of internet service providers all across the nation pushing fiber to the home, right? We all trying to get that 1 gigabits per second at a minimum, if not more. We're trying to, again, get a direct fiber connection to your home. And this is just for a few TVs and a few devices that we're using, right? The iPads, the iPhones, the Android devices. And why is that such an attractive option is because we get more for the buck. We have obviously a lot more family members who are utilizing the data more simultaneously, a lot more smart devices at our homes that are utilizing the Wi-Fi. So for the enterprise, it simply translates into being able to scale this much, much more for not just today, but for future technologies. Future technologies are going to be significantly bandwidth hungry. We today are the creators of consumers of data, right? We all buy data packages, 2 gigs, 5 gigs, 10 gigs from our mobile service providers. The future, I think, is where we're not going to be consumers of data, but we're actually going to be generators of data. The future user is actually going to generate more data than they consume. And for the only way for networks to be able to support that or supply that, and the monetization is going to be very different, where tomorrow, instead of you consuming and paying X amount of dollars for 1 gigabyte, it might be you pay for uploading X amount of gigabytes or terabytes of data as a user. So for the enterprise, really, it's understanding how to monetize that. The technology answer is simple. It's simply required based on the applications. How do they create these new models of revenue streams and new ways of attracting the tenants? That's going to be obviously faster adopted by those building owners and users that actually understand this. And that's where we come into play as well to help with that, where we have some ROI models. We have some past use cases that we have done where we did copper, we installed copper, then amount of time and effort it took to replace all that copper as these newer bands took place. Was a lot more cost prohibitive than if they had gone in with fiber to begin with. So in a nutshell, I would probably kind of summarize it that way. I don't know if you had anything to add to that.
Well, no, you said it well. The only thing I would add is that, look, fiber, horizontal fiber, vertical fiber is a certainty. It's really going forward is not a choice. Simply because I think we have to understand that when we ask for more and more in terms of services, and they become like 4K video and now augmented reality, you know, all kinds of services like that, these are bandwidth hungry. They need more bandwidth. And those bandwidth cannot be sustained on copper. I mean, that's just a reality. It's physics. And if they are, it would be very, very short distance. So fiber is not, you know, whether I do it now or not, it's really, it's a certainty. And the good thing about fiber is that it is future-proof. I mean, unless the capacity is like 1,000 times what it is right now, the fiber can accommodate it. You can't say that about copper. Right now, if you even put Cat 8, I bet you anything in 3 years, you know, you need to put fiber to accommodate the bandwidth that's needed for all the different types of data that is going back and forth. So in my opinion, fiber is extremely important. As I indicated, that number, $150 billion will be spent on fiber for the same exact reason, because fiber is just really irreplaceable. It's really the certainty of the future.
Okay, great. The next question is kind of a two-part question. So is DAS ISAIS, and how will this benefit my 2.6 million square foot property?
Sorry, could you repeat what was the IDAS? Is that what it was?
Yes. So the first question was, is DAS ISAIS, AIS. And then the second part of the question was, how will it benefit my 2.6 million square foot property?
Lakshmi, you want to take that?
Yeah, I think there may have been a typo with that question with IFAIS, unless you were talking about specific something that I am not familiar with. So whoever asked the question, feel free to elaborate on that. But I think I'll address the second part of the question, addressing 2.6 million square foot property. Now, typically the first things that we, as an industry member, I as an engineer specifically, I'm always curious about what type of property, right? Because you could have a convention center, a stadium, all of them in sort of the realm of square footage in terms of the size. But each one of them could have a slightly different solution or a slightly different approach to what we're trying to do. Obviously, the most important thing would be to understand what are your needs today and what are your future plans to upgrade tomorrow, which a lot of folks are always interested in being able to support all the bands today and tomorrow, but also understanding, do we scale it over time versus having everything up front simply to be able to spread out the costs more logically. And of course, the stadium is probably going to have a lot more attractive nature for a lot of funding options available versus, let's say, a standard high-rise building. So a lot of different variables that go into that, but that certainly might require a little bit more of an evolved conversation, which we're more than happy to set up a conversation too. But we've deployed and built solutions for all types of venues, for all sorts of square footage, whether it's from 250,000 square foot all the way up to 10 million square feet. That's our bread and butter. That's typically what we have been doing for a long time.
Okay, referring to the first part of the question, I think the question is referring to infrastructure as a service, if I'm not mistaken. Is it DaaS infrastructure as a service? Well, could be. DaaS is a technology, infrastructure as a service is really a business arrangement. Yes, there are players such as ourselves, third-party operators who would come and build the DaaS and lease the users for it, either the carriers or the venue owners, whatnot. So yes, DaaS could be outright bought by the carriers or the venue owners, or it could be done as an infrastructure as a service. Yes.
Okay, great. The next question we have is, when will the iPhone support OnGo? Sorry.
Okay, the iPhone 11 that came out recently does support OnGo, or for the ones who don't know, OnGo is the brand name for CVRS. So it actually does support it. So if you have $1,000 and you want to go buy iPhone 11, actually the lower tier of that is only $700, but the upper ones are higher. But all of them support CVRS, so that's good news. Before that, we only had a few options, but I think now that the iPhone is out with CPRS, probably everybody else would support it as well.
Okay, so next question we have is, whether operating in a PAL or GAA environment, is the DoD on the hook for E911 compliancy?
911 compliancy, right now, it's really not all that bad. It hasn't really changed all that much. It's still plus or minus 50 meters 50% of time. I think next year becomes 80% of time, and the accuracy is not changing very much until 2022. It's just the percentage of probability goes up. I believe the venue owner or whoever owns the system basically is responsible for that. Not the integrator, not the vendor. but the venue owner or whoever owns the system is responsible for the 911 compliancy. Well, at the end of the day, I mean, the carriers are, but if you're talking about CVRS or something, then the local venue, whoever owns the CPRS network. If it is the carrier frequencies, it's just they are responsible for it, whether it's indoor or outdoor.
Okay, I think I'm just going to give it just another second to make sure nothing else is going to come through. I think we're good. Okay, well, that is the last and final question, it looks like, from our chat. Want to go ahead and thank everyone for joining our webinar today. If you guys do have any additional questions, please feel free to reach out to us at marketing@solid.com, and we will direct you to either Nadir or Lakshman to help answer those questions. Just a quick reminder, there will be a recording sent out to everyone that has attended or was planning to attend today, and it will be sent out about 72 hours from now. Thank you all again for joining, and have a wonderful day.
Thank you.